Welcome back, everyone. I'm Michelle Sander, and today we're going to be talking about the CLEAR method of writing for science. So scientific writing can be divided into 5 different parts using the acronym CLEAR. C stands for claim, L stands for lead-in, E is evidence, A is analysis, and R is repeat. So let's take a second and we will go over what each of these means. For your claim, you want to write a statement or conclusion that clearly answers the original problem or question that you're posed. A lead-in gives some relevance or why should I care factor to the claim. So you want to give context, you want to give relevance. Why should the reader care? Why is it important? The evidence that you present needs to be scientific data that supports your claim. It needs to be appropriate to the question that you're being asked and sufficient. That is to say, you need to make sure you're only including pieces of evidence that are relevant to the question and not extraneous. You also want to make sure that you have enough evidence to fully support the claim that you're making. An analysis is really important, and a lot of students get hung up on this. It's not simply enough to state your evidence. You have to explicitly say why your evidence supports the claim. So the analysis is the really important connection language. Why does the piece of evidence that you've presented answer the question? You need to make sure you understand why the data counts and make sure you apply appropriate scientific principles. This is a really important piece where you can add in all of the language that you've learned over the past unit or all of the language that's relevant for the topic that you're studying. Finally, repeat. Most of the time, it won't be sufficient to give only one piece of evidence to support your claim. You'll need to give multiple pieces of evidence, and that's where the R comes in, repeat. So starting back with a new piece of evidence, don't forget to give an analysis of that second piece of evidence to tie it back to the original claim. And with that, you'll be able to write a clear scientific paragraph. This allows us to organize our scientific writing with ease and to provide strong arguments to support our claims. We're not interested in being long-winded in science. We're interested in getting straight to the point. So use this template to organize your writing and get straight to the point. Let's look at some examples similar to what's going to be on our exam. So explain why you agree or disagree with this statement. Gases have a higher temperature than solids or liquids. Write a clear paragraph answer to explain your thinking. The claim should specifically answer the question, gases have a higher temperature than liquids or solids. Your claim will either be, yes, they have a higher temperature, or no, they do not have a higher temperature. You're writing a claim that either accepts or refutes this premise. Your lead-in should give some context. Why do we even care about gases and temperature and solids and liquids? What relevance does that have to our lives? Your evidence would be from some of the demonstrations you saw, the notes that we've taken in class, the readings that you've completed, or observations you've made in your everyday life. The analysis piece will tie those pieces of evidence back into the claim that you're making and show how they support or refute the statement that gases have higher temperatures than liquids or solids. Finally, with the second, third, and fourth, or however many pieces of evidence that you decide to present, you'll repeat those steps. You'll analyze the evidence and tie them back to the claim. So stop the video for a moment and see if you can write a very brief paragraph using the claim, lead-in, evidence, analysis, and repeat method to support or reject the statement, gases have a higher temperature than solids or liquids. Pause the video and do that now. Here's another example of a question that might appear on our exam. Cynthia has a large glass of pure water. She puts the glass on the scale and it reads 50 grams. Then she pours in 6 grams of salt and she stirs it up without spilling any water. When she is done, she does not see any salt crystals in the glass. Why can't she see the crystals now? Where did the salt crystals go? Explain using words and a diagram to show your reasoning. If she were to put the glass on the scale, what would be the total mass? And you could choose one of these answers. 50 grams, more than 50 grams, but less than 56, exactly 56 grams, more than 56 grams. Your claim will basically pick one of these 4 options and ask you to explain why you chose that answer. So pause the video, take a shot at writing a clear paragraph that follows this prompt, which is similar to what you're going to see on the exam. And then when you're done, we're going to go over them in class the next time we meet. So what's most important for you to know is how you're going to be assessed on this skill. Our following exam is going to have two components. We'll be doing some unit conversion problems, and we'll also be writing a clear paragraph to support the particle model of matter. Take a look at the rubric below so you can understand exactly what you need to provide in order to gain a top score. 4 is the highest score you can get, 1 is the lowest you can get, and of course, if you don't complete anything, then it's a 0. I hope this gives you some clarity about what to expect on the next exam. We'll be reviewing those clear paragraphs, examples that you wrote in class next time we meet. I hope you're having a great day, and I'll see you soon.